Hi there, part two of eighth grade, week five, eighth grade science. We left off talking about ionic compounds, and basically that you need to be able to figure out the charges that each atom will become. What type of ion? Will it be a cation, positive charge, and what charge? Plus one, plus two, plus three. Or will it be an anion? What charge will that have? Minus three, minus two, minus one, depending on the periodic table and how many valence electrons it has. So when you do an ionic substance, though, when you do like this easy one we left off with plus one, minus one, it becomes just Kf. You keep the charges off of it. And that's because plus one, minus one will become neutral, and you just write Kf. And again, metal always goes first. What you end up forming there by putting those together is called a empirical formula. It's the simplest ratio of atoms that we'll get to when you get to chemistry. So if we look here, ionic bonding, as we said, we call it a formula unit because it's a simple whole number ratio. It's not really, if I was just to say Ki, it's 1-to-1 ratio. So if we look here, there's actually 7 anions that are green and 7 purple cations. It's still a 1-to-1 ratio. Now, when we do covalent bonding, what we put in our molecular formula will be the actual number of atoms. So if I just said Ki, it could be this right here. It's a mass of positives and negatives all grouped together. Don't really worry about the actual crystal structures right now. So what we want to look at is some of the properties that form from ionic compounds. And some of the properties you end up getting is the fact that they have high melting points. So ionic solids, we won't spend a lot of time on this, but it's good to kind of time to go through. It's pretty easy. Which one's going to have a higher melting point is going to be the one with the least number of ions that I look at. So if sodium fluorine is plus one and minus one, those are just 2 ions, will have a higher melting point than Na, sodium and phosphide, P, because phosphorus is a -3. Now, when you actually form that compound, it won't be NaP because we need the charges to cancel out. So I take this 3 as a subscript and put it down in front of the sodium, which means I have to have 3 sodiums to match up with 1 phosphorus. So it ends up giving me technically 4 different ions there because there's 3 sodium ions that have to match up with 1. That's 4 total. So the fact that this has more ions means it's got a lower melting point. Now, if we look at some of these, arrange them in order. Let's first look at their charges because that's the main thing you got to know. Calcium is always +2 because it's in the second column. So it's got 2 valence electrons. Gain 6 or lose 2, it always loses 2. Phosphorus has 5. Gain 3 or lose 5, it gains 3. Now, how do you find the formula? Take the 3. If they don't match up exactly, take the 3 down to the calcium and the 2 down to the phosphorus, not the charge. Na is +1 because it's in the first column, and iodine's in the last column, 7, so it only needs 1, +1, -1. Here's some of these groupings. As I said, you don't really have to worry about that one today, but magnesium's in group 2, so it would have gain 6 or lose 2, it's going to lose 2. Chlorine is in group 7. Gain 1 or lose 7, it's going to gain 1. And notice 1 goes down to here. I never have to write the 1 because if I have 1 magnesium, it's good. And then the 2 comes down on the chlorine to form the formulas, the ionic compound formulas. Now, if we wanted to rank them according to their melting points, the one with the least amount of ions, look at sodium and iodine, each have just 1 sodium, 1 iodine, so that's 1. If I look at magnesium, it's a 2-to-1 ratio. There are 2 chlorines to 1 magnesium, so that's only 3 total. So that's 2. If I look at magnesium and sulfate, it's +2 and -2. So you have 2 of these and 2 of these. That's 4. That's third ranking, but you're not going to have to rank them. So you can look through the rest of the PowerPoint if you want to. But if we know it's an ionic compound, it's a metal, nonmetal, cation, anion, and will always form the simplest ratio of atoms when you do the crisscross method I just talked about. If I want to know the strength of the bond, it's the difference of the charge, and the strength of the bond is also going to tell us the melting point. So atomic radius, give this. I'm not going to worry about you ranking them in this case because the strength of the bond or the which one has the highest melting point will be the one that's stronger.